I'm going to give you something to copy on Canvas for your notes. So I'm logging on to Canvas because today, remember, okay, there's no check your understanding, but you guys remember your assignments are due today. You guys know what assignments are due, right? So make sure you get those in. If you have questions, look it up. If not, I can show you what to turn in. It's Friday. Obviously, you turn in your assignments on Friday. So, okay. We're on 5.4, properties of logarithms. And there it is. And there it is. And there it is. And there it is. Okay. Copy this down. Where do I take roll? I think it's this one. Okay. The properties of logarithms. So, let me go. Actually, before you copy, let's write down the topic. Should do that. What is the topic? So here's the topic. And I know I'm not showing to you because I gotta like switch my screen around. Let's click the stop presenting. And let's go present my entire screen. Okay. We're doing 5.4, 279, 3 through 39 odd. We're doing all of them. I mean, all odd, not every other odd. We're doing all the odd. Expanding logarithms or properties. I'll get out. I know my hand's in the way. Of logarithms. Properties of logarithms. Okay. 5.4, page 279, 3 through 39 odd, expanding logarithms or properties of logarithms. Okay, so write these properties down. Write these properties down, these properties of these logarithms. Right here. These properties right here, write them down. The product property, the quotient property, and the power property. Power. What's the power property? Well, I take roly roll. I think you guys can still, can you still see it? Let me know if you can't see it. Julissa Abonse.
Here.
Sam Adams.
Here.
Ayume Anderson. Naveed Atashbar.
Here.
Cassandra Casillas.
Here.
Brianna Cuenca. Nathaniel de Guzman.
Here.
Miley Fisher.
Here.
Aaron Giron. Carlos Gomez. Billy Gonzalez.
Here.
Brett Hare.
Here.
Lorenzo Lemus.
Here.
Linda Lopez Hidalgo.
Here.
Maya Lopez.
Here.
Angel Lopez. Abraham Lucio.
Here.
Ethan Montes.
Here.
Emma Montoya.
Here.
Melissa Moreno.
Here.
Connor Alasso.
Here.
Mara Ortega.
Here.
Montserrat Pedrosa. Ian
Here.
Ramirez.
Here.
Angel Rojas. Thomas Servin.
Here.
Samantha Velasco. Alonza Vitella.
Here.
Dennis White.
Here.
Elise Williams.
Here.
Okay, here's who I've absent. Ayume Anderson, Cassandra Casillas, Brianna Cuenca, Aaron Garon, Carlos Gomez, Angel Lopez Garcia, and Angel Rojas. Ayume, are you here? Cassandra, are you here?
I'm here.
Brianna. Aaron Garon. Carlos Gomez. Angel Lopez Garcia.
Yeah, I'm here.
Angel Rojas. Okay, again, here's of absent. Ayume, Brianna, Aaron, Carlos, and Angel. Are any of those people here? Ayume, Brianna, Aaron, Carlos, and Angel Rojas. Ayume Anderson, Brianna Cuenca, Aaron Garon, Carlos Gomez, and Angel Rojas. All right. Okay, hopefully you copied that down. Let me explain what's going on here. Okay, so these are just properties of logarithms, and basically, really, what's going on here? What's going on here? I always get confused when they show stuff with the letters, and the numbers always help. But log b m times n is the same as log b m plus log b n. As long as the base is the same, I can split it up. So it'd be like saying log 718. Log 718 is the same as log 7 6 times 3. Right? Notice I got log 7. I can make that into log 7 6 plus log 7 3. It's all based on, when you multiply, sorry, this is multiply exponents. When you multiply two bases the same, you add the exponents. Well, these end up being like the exponents, and that's what the property comes from. Comes from that. The quotient rule, now instead of adding, we subtract. Log base m divided by n is log base m minus log base n. Log 512 divided by 16 is log base 512 minus log base 5 6. Sorry, I said 16, I meant 6. That's how you would split it up. We'll do some of these in actual practice so you can see what's going on here. And then finally, the power rule means if I have a log base m raised to the nth power, I could bring the n in front. Or if I did in numbers, log base 3 5 to the second power, I can write it 2 times log base 3 5. Okay? And then I'm going to get into the change of base rule in a second, but right now let's focus on those. And there's another rule called the change of base rule. So are there any questions on these rules that I have? The quotient rule, the product rule, and the power rule. Power. Sorry, I'm going to get rid of this in 10 seconds. Yeah. Oh, it's so cool. Power. Okay, let's get on the lesson. Let's get on it. All right. Alonzo.
Yeah.
How's that? Those rules, do they make sense or are they kind of weird?
Pretty weird, but they make a little bit of sense.
Well, let's do some problems. You'll see. What do you think, Elise? Sorry, Alonzo. Did I cut you off? What did you say, Alonzo? Were you saying something else?
No, you're good.
All right. What do you think, Elise?
Yeah, they're pretty weird.
Pretty weird. Well, let's do some problems. Okay. Let's look at number 3. Now, this is really weird. Okay. So let me show you what they mean by this. They're telling you that log 7.4 is approximately 0.712 and log 7.12 is approximately 1.277. Okay, so I'm going to write it up here. Log 7. I know I'm not presenting. I will present in just a second. I'm just copying it off. 0. You guys, I'm writing the log 47 is equal to approximately 0.712 and log base 7.4. No, reset. Log base 712 is equal to 1.277 approximately. Now, with all that, they're saying, hey, yo, we know that. They're saying, what is the log 7 base 7.3? Okay, well, we can use the quotient rule for this. Am I recording? Should I record this? I'm going to record this. Oh, I am recording. Oh, man. Oh my gosh. I am so on it. I am so on it. Dang. Dang. I thought I wasn't recording, but I was recording. I'm just like, ugh. You don't even understand what an amazing teacher you have right now. You don't understand that. You guys got to realize what an amazing teacher you have right now. Didn't think I was recording, but I recorded it. You know? Lorenzo, you know what I mean? Do you understand?
Yeah.
No, you don't. You don't understand how amazing your teacher is. Ethan, do you understand?
Yeah.
No, you don't. You don't understand how amazing this is. I know you're thinking this class ends in about 30 minutes. I'm so sad because I can't see Sensei's amazingness anymore. What, right, Billy? Am I right, Billy?
Yeah.
Ah, yes, that's what I'm talking about. Wait, what am I doing? Okay. Sorry, I had to pat myself on the back there. I don't even know what made me amazing. You know, Melissa, why am I amazing again?
Because you were recording the class.
Oh yes, there you go. Okay, so here we go. We're recording this. Okay, so log base 7.4 is approximately 0.712. Log base 712 is 1.277. So let's rewrite this as, watch what I write this. So how can I make this equal to 3? I can write it as log base 7, 4 divided by 12. Sorry. Oh my gosh. I take it back. I'm a horrible teacher. Log base 7, 12 divided by 4 is equal to 3, correct? So then I can write that as, using the quotient rule, it's log base 7, 12 minus log base 7, 4. The quotient rule says that if I'm dividing this by this, I can make it a subtraction problem. And then I know what log base 7, 12 is. It's 1.277 minus log base 7, 4 is 0.712. And then you just subtract those. 1.277 minus 0.712 is equal to approximately 0.565. That's it. All right, let's see who understands that. I'm checking you guys. Oh, let me go back. I'm going fast. I'll leave it there. Are there any questions?
Is that 0.565?
Yep, that is. Any others? We get rid of this in 5 seconds. No, 10 seconds. Now 5, 4, 3, 2, 1. Okay, let's see. All right, how's this? How is that? Let's go with, did that make sense with, let's go with, Brett, how was that?
Pretty easy.
Okay, what do you think, Connor?
Oh yeah, well, pretty easy.
All right, well, that's good. If you did not think it was easy, that's fine, because you've never seen this before. But we'll just keep doing another one. I'm going to do 7. You guys have to do all of them. I'm going to do the first and last in each section, assuming the first is the easiest, the last is the most difficult. So log 7 to the 1/4 power. This is log 7, 16 is log 7, 4 times 4 is log 7, 4 plus log 7, 4. But anyway, let's write log 7, 1 to the 1/4 power. Now, this one was weird. I'd actually looked at the answers in this one because this was kind of weird what they wanted us to do. It's not weird, but you just have to really be creative. Log base 7 to the 1/4 power is equal to log base 7 to the 4 to the -1 power, right? If I put a negative there, it's the reciprocal. Questions on that step? So now, what I can do using the power rule. What does the power rule do? What does the power rule do? I'm telling you what the rule is going to do, what rule you use. What does it do? What is the power rule? Dennis, tell me what the power rule is.
Log mn equals n log m, right?
Okay, so what just happened there? Because I'm not looking at it. You just described to me. Pretend you're just telling my 10-year-old daughter what to do.
Oh, wait, I'm not sure. Kind of confused on it.
Confused by it?
Yeah.
Okay, well, stay with me, Dennis. Emma, help Dennis out. What is the power rule?
The power
What?
rule?
What? What is the power rule? Describe, like, if you're to tell my 10-year-old daughter what the power rule does, or what's going on with the power rule.
It moves the -1 in front of it.
Yes. What it does, yes, that's perfect. That's what I tell my 10-year-old daughter to do it. Is it takes the exponent and it puts it in front of the logarithm. That's what the power rule does, right? The power rule. Look at your notes. Dennis, did you see that in your notes? Or I don't know if that makes sense or not. I feel like I should show you.
I get it. I get it now.
You do?
Yeah.
Well, I'm showing you now. All it is it takes the n and it puts it in front. Power rule puts it in front. So knowing the power rule, I think like Emma said, it goes -1 times log 7 to the positive 4. The power rule lets us know that. Now to calculate it, I know what log 7 to the 4 is. It's 0.1712 times -1. So -1 times that is -0.712. And that's all you got to do. That's your answer. Okay, so moving on. Let's go to, all right. So now 9 through 12. Okay, so now we're using these quotient rules to help us understand what's going on here. I kind of breezed out through my other class and it was confusing to them. So I'm just gonna do the first and the last. Well, maybe I won't even do the last, but 9 is log 3, 6 minus log 3, 2. Log base 3, 6 minus log base 3, 2. What does that equal? Does it equal A, B, C, or D? You got to match them up. So we can use, what rule am I going to use for this? The quotient or the product or the power rule? Which rule am I going to use? The quotient or the product or the power rule? What do you think, Linda? The quotient or the product or the power rule for that? Linda?
The quotient rule?
Yeah, very good. So let's use the quotient rule. Because I have the same base, I can make this log base 3, 6 divided by 2, the quotient rule. And then that means it's log base 3, 6 divided by 2 is 3. And so you just see if that matches up there. That's all you got to do. All you got to do. All you got to do. How about that? Okay. So log, it's B, right? Now let's look at 11. 6 log base 3, 2. Okay. What rule am I going to use for that? For 11? The product, the quotient, or the power rule? Number 11. I have it highlighted. Look. Whoa, it's so big. Whoa. Oh my gosh, 500% zoom. I can't zoom it anymore. It's as big as it gets. What do you think? Power quotient or product rule? Power quotient or product rule to solve this one? What do you think, Miley?
The power rule?
The power rule. I didn't even write it down. Let me write it down. Oh, no, I did. I did write it down. So let's do the power rule. So all I do is that means I bring log 3, 2. Instead of it here, I bring it here. Boop, boop. 6. And 2 times 2 times 2 times 2 times 2 is 64. Let's see if it matches up. But that's all you got to do with those rules. So let's see if it's there. Smaller. There it is. It's A. All right. Am I going too fast? Expand. So now we're going to, instead of compressing it, we're going to expand it. So let's look at 13. What rule are we going to use for 13? 13 is log base 3 4 times x. We want to expand it. I'm going to do the first and the last. If you're not first, listen to me. If you're not first, you're last. I'm telling you, that's an important lesson in life. If you're not first, you're last. Thomas.
Yeah.
Hey, what am I going to use here? What do you think? The product, the quotient, or the power rule?
The product.
Yeah, because I'm multiplying 4 times x log. So expand it. I change it to an addition problem. Log base 3, 4 plus log base 3x. And that's all you got to do. Let's go to the last. Are there any questions? You ain't first, you're last. If you ain't first, you're last. Okay, 19. Okay, so now I got a couple of them here. Log base 7, 5 times x square root of x. Okay, I better shut my door. There, I'm yelling too much. Okay, I'm an annoying dad and husband sometimes. So I'm going to use the product and the power rule. Product rule, log base 7, 5 plus log base 7 square root. Sorry, this is supposed to be an x. Log base 7x. Now, I'm going to rewrite this as log base 7, 5 plus, so I can use the power rule, log base 7 x to the 1/2. Remember that to the 1/2 is the same as the square root. And then following full expansion, it'll be log base 7, 5 plus, using the power rule, 1/2 log base 7x. That is full expansion right there. Okay, any questions on that? That was 19. All right. Melissa, how's it going? How am I doing?
Good.
All right, Melissa, I got a question here for you. The
Yeah.
error analysis, log base 2, 5 times x. What's wrong with this? Log base 2, 5 times log base 2x. What's the problem here?
You're supposed to add
There
them,
you go.
not multiply.
Product rule. That's what I'm talking about. Very good, Melissa. Way to knock that one out. So there's 21. Everyone thank Melissa. Move on. Let's look at 23. Okay. Now we condense. Okay, so now we're just doing the opposite. We just condense them, right? So I'm going to do the first and the last. I'm going to do 23 and then 29. Okay, so 23, condense. 23 is log 4, 7 minus log 4, 10. So what rule am I going to use? What rule? What rule am I going to use? Let's go with, I keep flipping. That's not, oh my gosh. Oh no. Okay, let's go with Julissa. What rule am I going to use?
The quotient rule?
Yeah, the quotient. So I just write this as, do you know what the answer would be, Julissa? Log base 4 what? Can you tell me that?
No, I don't know.
It's not going to be a whole number. It's going to be a fraction. Does that help?
10 10/7.
Ooh, close. Actually, the first number is the numerator and the second number is the denominator. It's like in order. I don't know if that makes sense, Julissa. I say it's in order. Does it or no?
Yeah, it makes sense.
All right, cool. Let's do the last one on that section. Thank you, Julissa. That was awesome. Okay, let's go with boom, 29. 29. 5 natural log 2 plus 7 natural log x plus 4 natural log y. Natural log. Whoop. Natural log is just a log with a base of what? What is my base for the natural log? What is my base? What is my base for the natural log? Let's go with Ian. What's my base for the natural log?
I'm trying to find it in my notes right now.
I'll give you a hint. Ian?
Yeah. Yeah.
It starts with the letter E.
E.
Yep, that's right. It's
Just
just
E?
E. It's
Oh,
log
okay.
base E. Do you remember that?
Yeah, now I remember it from last lesson.
There you go. Very good, Ian. So now to expand all these, let's look closely. Notice all these have the number in front. How can I make these numbers go together? Let's use the power rule. Natural log 2 raised to the 5th plus natural log x raised to the 7th plus natural log y raised to the 4th. Now they all have the same base of e, so I can combine them. But before I do, let's go ahead and multiply out the 2 times 2 is 4 times 2 is 8 times 2 is 16 times 2 is 32. Natural log 32 plus natural log x to the 7th plus natural log y to the 4th. Now, because I'm all adding them, I can just multiply them and throw them together. I'll pause because I'm going so fast. I'm just like super fast. I'm just going fast. Are there any questions? I just can't even believe how fast I'm going. Just crazy. Just ridiculous. Ridiculous. Natural log 32 times x to the 7th times y to the 4th. Using the product rule, we just put all those suckers together. 29. 29. Oh, I love you. 29. Yeah. Lego Master Sergeant. Yes, sir. Yes, I'm going to space. All right. You did good on that problem. Thanks, Lego Master Sergeant. No problem, Sensei. I'm going back to space. All right, Lego Master Sergeant, what happened to your arm? I lost my hand in battle. Oh my gosh, that's terrible. I'll see you later. All right. Thanks, Lego Master Sergeant. You're so kind. Okay. Let's go to... What are we going here? Not that one. That was 29. Am I going too fast? Tell me if I'm going too fast. Okay, this one you're just going to have to expand. There's all different things, so you're going to have to play around with that. You do 31 on your own. 33. Let's see. Okay, here we got to do the change of base formula. So let's look at the change of base formula. What is that? Now, we're going to calculate what this is. But remember, on our calculator, this is log base 4. We need a log base 4 in order to calculate that. But we can't use our calculator because what does our calculator have? What's the base number on our calculator? Connor, what's the base on our calculator?
10.
10. I need a 10. So we have to change the base. We have to change the base so that I have a base of 10. And here's how you do it. I'm presenting to everyone. Whoa, microphone. Where is that change of base formula? There it is. So write this down. This is the change of base. However, log base CA equals log base BA divided by log base BC. Now wait, here's the one I want you to write down though, because this is more pertaining to you, because this is in particular. Log base CA equals log base 10A divided by log base 10C. Write that down. You can also do it with the natural log too, because it has the same base of E. You can do it with the natural log or the log. Either one will work. But write log base CA equals log base BA over log base 10A divided by log base 10C. What are you saying, Sensei? Oh my gosh. CA equals log A divided by log C. And here we go. I have it written out right here. This is the change of base. Let me write it out. Change. I just wrote down what I want you to write down. Change of base. Log base C over A equals log base A divided by log base C. Now, you can also use natural log because you have the natural log on your calculator. Log base C of A is equal to the natural log of A over the natural log of C. Now you're saying, Sensei, this is confusing. What the heck? I forgot. What time is it, by the way? 2:57. Okay, here we go. Let's use this. Let's do this problem here so we can get an idea of what is going on. What is going on? So, number 33. How do I solve? Let's write down what's going on here with number 33. It's saying log base 4, 7. Okay, and I'm going to continue that. Okay, so here's number 33. Log base 4, 7. Here's my change of base above it. Got a question. I'm just going to write this here. It's not on the problem, but I'll put a little question mark. What does that equal? So let's change to exponential form so we can get an idea. Exponential form, log base 4. Remember, we switch these. What is that equal to? So what's that saying? What do I raise 4 to what? Remember we talked about this yesterday? I raise 4 to what power to equal 7? Okay, so this is how we use this in logs. Change of base. So we're trying to figure out the exponent. 4 to the what power equals 7? Change of base tells me this. Log base 4 over 7 equals, notice the A, the big is on the numerator. The C, the lower one, is in the denominator. So that's going to equal, here it goes, ready to change a base. To solve this, you just write log 7 over log 4. Boom. That's all you got to do. That's log base 10. Then you take your trusty dusty calculator. I'll pause so you can think about what I just did there. Just put the 7 on top, numerator, 4 on the bottom, denominator, and you just go calculate it. Log base 10, 7. Hit log 7. Log, you see that? 7. Hopefully you can see that. Divided by log 4. Log 4. And what does that equal? 1.4037 approximately. Just 3 decimal places what you need. I'm going to do 4 though. 1.4037. That's what the answer you should have got. And that's the change of base. So 4 to the 1.4037 power will equal 7. Let's do the last. Are there any questions on that? That's the change of base. Change of base using logarithms. Oh, woo! Okay, one more. Let's do 39. I'm going to do 39 really quick. Log base 7, 3 over 16. Now, let's do the change of base. So look, before I put the 7 in the numerator and the 4 in the denominator. So here I'm going to put 3/16 in the numerator and 7 in the denominator. That's it. It's just that it's a fraction. Find the log of 3/16 divided by log over 7. Log, how do you enter that? Am I going too fast? Are there any questions? Should I pause? I feel like if I turn my light on, it'll be a glare. I have a light on this, but it like glares it out. Oh, maybe that looks better. I don't know if you guys can see that better. So no, that doesn't really help. So I hit log, I'm hitting log. Well, you can kind of barely see it. Then I hit for the fraction, do 3 divided by 16, close parentheses. So you get the 3/16, all divided by log, make sure you do the parentheses, log 7, close parentheses. Then we hit equals, we get negative 0.8603. Kind of cool. So do all the other, I did up to 39, do all the others in between, all the other numbers in between. Are there any questions? I'm gonna get rid of this in 10 seconds. Okay, I have an announcement, and then I'll dismiss you. Make sure you get your assignments in. There is no check your understanding tonight. Make sure you get your assignments in. This assignment I'm going to collect next Friday. You don't turn this one in today. You turn it in next Friday. It's not due today. The one we just did, it's not due today. It's due next Friday, so don't sweat it. I just did my class recommendations, what classes you guys should take next year. This is kind of early, but they ask us to do it. If you have an A, B, or a C, I recommend you for pre-calc honors next year. Okay, pre-calc honors. If you have a D or an F, currently, I recommend you for Math 3 CP. If you want to talk to me about that after class, you are more than welcome to. Are there any questions? See you tomorrow. You guys can go. Have a good one. Bye, Thomas. Bye, Samuel. Bye, Emma. Bye, Alonzo. Bye, Angel. Oh, Angel, what did you say? I don't even know. Bye, Connor. Bye, Julissa. Bye, Nathaniel. Bye, Linda. Bye, Billy. All right. Abraham, what's up?
Hey, I just I was able to do the questions from yesterday, except the last one, which was the graphing one. I mean, I got some numbers right when
The
I was
one I
like,
did I did that one, right?
but there was one afterwards.
Oh, okay. Hang on, let me find it. What number? Give me the number.
I stapled it. And the way I stapled it makes it like 57.
Okay. So let's write it out. Did you write it in exponential form?
Exponential form?
To graph it, it's way easier to see in exponential form. It's in log form now. Y equals log 1/3 to the x. Okay. Let me present. Are you on it? You have the problem?
Wait, I can't see the problem.
No, but are you on it on yours? You ready to go? What's up, Ethan? Do you have a quick question?
When did you already end class?
I did. Class is over, yeah. What happened? Did you get kicked off or something?
Yeah, I think so. Because it said The connection was lost to host.
Oh shoot. I did. How long ago were you out?
Just